Okay, so let's jump right in. You know, we're surrounded by millions of cameras, right? They're on our streets, in warehouses, even watching over forests. But what if those cameras could do more than just, well, record? What if they could become our ultimate frontline defense against one of the scariest things out there, fire? I mean, just think about it for a second. The smoke alarm in your house, it's great, but it has one huge flaw, right? It has to wait for the smoke to actually reach it. So today we're going to talk about a total game changer in fire detection. We're talking about using AI to see a fire the very second it ignites. And really, the whole thing boils down to this one simple idea: a point sensor versus a volume sensor. Your smoke alarm? That's a classic point sensor. It just sits there, waiting, passively, for smoke to drift over to its little spot. That delay, even if it's just a few seconds, that can be everything. The difference between a little contained fire and a full-blown disaster. But a camera, that's a volume sensor. It's watching the whole room, the whole area, all at once. It sees the fire the instant it happens. And it doesn't just tell you, hey, there's a fire, it tells you exactly where it is and how big it's getting. All right, so first up, let's talk about the hardware. The eyes of the system, these silent sentinels that, believe it or not, are already everywhere. And this is really the beautiful part of this whole idea. We don't need to go out and build some brand new expensive infrastructure. The cameras are already there, millions of them. They're watching 24/7. So the real challenge isn't about installing new stuff. It's about upgrading the stuff we've already got, making it way, way smarter. And yeah, the researchers really hit the nail on the head with this. They say, quote, video is a volume sensor, not a point sensor. By watching a whole area, the chance of catching a fire early just goes through the roof. It's a total flip of the script, you know? We're going from being reactive, waiting for the alarm, to being proactive. The camera doesn't wait for proof, it sees the event in real time. Okay, so we've got the hardware, but how do you actually teach a machine to, well, see fire? Let's get into the software. So the first attempts were kind of clunky, you know? Programmers basically tried to write a strict rulebook for the AI. They'd tell it things like, okay, look for the color orange, look for a flickering motion, look for blurry edges. It made sense at the time, but the real world is messy, and this super rigid rulebook just couldn't keep up. And yeah, that was the big problem. This simple rulebook meant a ton of false alarms. What happens when the AI sees a red flag flapping in the wind? Or a beautiful orange sunset? Or just a pair of car headlights? All of those things kind of fit the rules, and it totally confused the system. It was clear this just wasn't going to work. The modern solution? It's all about deep learning. Instead of that strict rulebook, we do something that sounds a lot more human. We let the AI learn from experience. We just show it thousands upon thousands of videos of real fires, and videos of things that just look like fire. And over time, it starts to pick up on the subtle patterns all by itself. It develops its own kind of intuition, one that's way more powerful than any set of rules we could write. So what the AI is actually doing can be broken down into three big tasks. Think of it like a ladder. First is just recognition. It's a simple question. Is there a fire in this picture? Yes or no? Then you climb up a rung to detection. Now the AI asks, okay, where is the fire? And it draws a little box around it. But the top of the ladder, the real magic, is segmentation. This is where the AI asks, what is the fire's exact shape? And it outlines every single pixel of the flame and smoke. That level of detail is a complete game changer. Okay, this is where things get really, really interesting. Because researchers started to realize they weren't just trying to solve one big problem. They were actually dealing with a bunch of different, smaller problems, all masquerading as one. See, for a long time, everyone just split the problem into two buckets. You had urban fires and wildfires. Seemed logical, right? But it's way too broad. Think about it. Spotting a fire in a quiet forest where nothing else is moving, that's a totally different beast than trying to spot a fire in a busy traffic tunnel. With all the cars, the flashing lights, the reflections, the background, the environment is just as critical as the fire itself. So what they came up with is this amazing new framework. It's a simple 2x2 grid that breaks the problem down based on the two things that really matter. First, range. Is the fire close and big in the frame or far away and tiny? And second, activity. Is the background quiet and calm or is it super busy and chaotic? When you put those together, you get 4 totally unique scenarios, and each one needs its own special kind of AI to solve it. So let's dig into that first one, range. And this isn't just how far away is the fire in feet or miles. It's about how big the fire appears to the camera. How many pixels does it take up on the screen? At a short range, a fire is obvious, right? Big flames, lots of smoke. But at a long range, a wildfire starting miles away might just be a couple of blurry pixels. You might not even be able to see flames. Your only clue could be a tiny little puff of smoke on the horizon. And then there's activity. This is all about visual noise. How much other stuff is going on in the background? A low-activity scene, like an empty warehouse at night, is easy. It's predictable. But a high-activity scene, like that busy tunnel or a factory floor with workers and machines moving everywhere, that's just chaos for an AI. There's so much movement, things blocking the view, and a million things that can look like fire. Headlights, reflections, warning lights. This is probably the single toughest challenge in the whole field. So, armed with this new 4-box framework, researchers went back and looked at the data we have to train these AIs. And what they found was a huge, glaring problem. It turns out that when you look at all the public video data available for training, almost all of it, a whopping 97.8%, is from those easy, low-activity scenes. You know, the quiet forest, the empty room. That leaves a tiny, tiny sliver, just 2.2%, for those really difficult, high-activity scenarios. This is a massive imbalance, and it's a huge problem if we want an AI that works in the real world. Let me just put that number into perspective for you. That 2.2%, it comes out to a grand total of 8 videos. 8. That's it. For all the researchers in the world trying to solve the hardest version of this problem, they have a library of 8 videos to learn from. EIGHT. You can't build a powerful, reliable AI with that. No way. But you know what? Finding the problem is half the battle. Now that we know where the gap is, we have a crystal clear path forward. And that roadmap looks something like this. First, we've got to build better data sets. We need to go on a data hunting mission for those tough, high-activity scenarios. Second, we stop trying to build one AI to rule them all. Instead, we create specialists. One AI model for warehouses, another for forests, and so on. Then, we need to make these models lean and mean, lightweight enough to run on small devices like drones. And the holy grail, the final step, is moving beyond just detecting a fire to actually predicting where it's going to spread next. I mean, can you imagine giving that kind of superpower to firefighters? Look, the tech is moving so fast. We know the challenges now, but we also know the solutions. So really, the question isn't if every camera is going to become a silent guardian watching for that first wisp of smoke. The question is just when. And how much of a difference will it make when they finally do?